Elisabeth Hendrickson, and today I am joined by my dear friend Naresh Jain. And Naresh, you and I have actually known each other for a really long time. I think the first time that we met in person was at the very badly named AAFTT, the very first AAFTT meeting. That was the Agile Alliance Functional Testing Tools meeting in October 2007 in Portland. That was the
Wow.
first time we met in person, right?
Yeah, I believe so. Yeah, it's almost 20 years now. It's a
And
long time ago.
oh my goodness, I know, right? And so much has changed, and we're going to talk about that. But I remember meeting you for the first time, and you were jet lagged. Like you had just flown in. You didn't have a lot of time before the conference started, and yet you kind of bounded into the room with this massive amount of energy and creativity, and you had so many things that you were working on. I was just blown away in that very short amount of time that we had together, and I'm grateful that I have gotten to sometimes follow from afar what you're doing, but I'm so excited to talk to you today about everything that you've been up to.
The feeling has always been mutual, Elizabeth. I mean, I've appreciated what you've done over the years, the transition you have made in your own career in many ways, like the role you've played at Pivotal and other very interesting things. So, the feeling has always been mutual. But unfortunately, we just not had time to do a lot of work together. So, that's the only regret I have.
It's a little challenging because we're half a world apart, but I you're very kind. Now, among the many things that you have done, you're an entrepreneur, you're a technologist, you're the founder of the Agile India community, and you've organized bunches and bunches of conferences: Agile India, Simple Design and Test, API Days, other conferences. Did I miss any?
Like Selenium, Appium, bunch of other conferences, functional programming conference, one of my favorite ones, open data science conference. So yeah, I think the thing that always has been a concern for me is I feel like in this part of the world we have very smart individuals, but they lack the exposure. And when you don't get exposed to the right kinds of things, all you get to see is a bunch of marketing bullshit conferences. Then you kind of just learn those things, right? So one of my goals has been to bring in the real movers and shakers to India and kind of get that exposure. But it's also more for selfish reason where I get to spend more time with the people I love to. So it works both ways. But yeah, so that's the kind of the secret behind the whole bunch of conferences and communities that we've been building around here.
And you ran so many conferences, you ended up creating your own conference organizing platform, right?
Convention, yes, that's right. So what ended up happening is that generally it's a volunteer. Like all these community-run conferences are essentially volunteering kind of activities where we do after work or late nights or over the weekend. And what ends up happening is that when you have things flying over emails and this and that, it's just very difficult to wrap your head around and make sure everything is going to fit together well. So the very first year we wanted to try and get the schedule in one source of truth for the schedule, and then how the proposals came in, what proposals got selected, did we provide the right feedback to the speakers who proposed the topics. So it just started like as a hobby thing to kind of automate a little by little. And then folks who use the system, they said, oh, this is cool, can we use it for our conference? And I was like, no, it's not. It's built for to work with only one conference at a time, right? It just doesn't even have the infrastructure. But that kind of led to maybe we should expand this, let other people use it. And along the way, I think it kind of ended up becoming a little bit more like a platform that other organizers continue to use. I'm actually surprised there's a whole bunch of conferences in Japan that use the platform. And I think last April I was in last April, as in 24, I was in Tokyo, and I finally got to meet a lot of those folks who were using, and I was amazed that they had kind of the same value system that we had built ConfEngine with. And so it's very interesting to see how you can build a platform and then kind of meet people with the similar value systems in terms of community events, and they kind of keep coming back to using the platform. So yeah, it's been a very interesting journey.
That's amazing. Want to come back and talk to that more. But in the meantime, the other thing is when you're not organizing conferences, you have this wealth of experience. You're working with enterprises, and you have this wealth of experience going in and actually working in the trenches with enterprises on their critical systems. So you've experienced firsthand the complexity and the scale that enterprises are dealing with every day, right?
It's mind blowing, right? Like some of these enterprises that you work with have systems that date back to the 1960s, and they've been running mission critical systems for them since then. So a lot of that code was written in all kinds of languages that people probably have not even heard. Sometimes even proprietary languages that are not publicly available. But it's fascinating, like when you see the kinds of problems these enterprises try to solve and the scale at which they try to operate. Sometimes it's just a wealth of experience to learn from. Even like systems which are very very stable and been running for many years. It's just amazing to even look at some of those systems and say, how is this even running? Right? It's like just amazing learning. Of course, they have their set of challenges, which is why they would bring folks like us in to kind of help out. But it's a two-way street. I feel like there's a lot for us to learn from their success, and a little bit of us to teach them in terms of the kinds of things we've seen, and bring some ideas and perspective to the table.
Yeah, and that's where you and I were talking before this call, and that actually is what led to this interview, because you and I were talking about stuff that we're both seeing in the industry right now, and we were both seeing the same set of challenges and patterns, and we ended up having this great conversation that I kind of wish I could have hit record on that. But I want to continue the conversation here. And you're talking about the critical systems that these organizations have, and they're operating at complexity and scale, but they also have to modernize. And one of the big trends over the last, let's call it, decade, was
Yeah.
shifting, modernizing, transformation, digital transformation, shifting to microservices. And there was a sense, kind of in the ivory tower view of the world, that microservices will solve all your problems. I am old enough that I
As
remember
always.
when COM objects were going to solve all your problems. And I worked with an organization a long, long time ago where, bless their fuzzy hearts, there were actually some people in the organization that believed that if you tested the snot out of your COM objects, and for those of you who have never worked with a COM object, don't worry about it. It's just this little hunk of code that runs in isolation. And they believed that if you tested the snot out of the little hunk of code, that then you didn't have to test the whole system because it would just work. And I think there might have been people who believed that about microservices.
I think that's true. Like from com, I think at least for me, my evolution has been like EJBs. Like there was a world of EJBs where people believe you can have these beans remotely or locally running, and you can just invoke them, and it would be transparent to you. And as long as you've tested the bean that it does what it's supposed to do, then the world is going to be a happy place. And I think we fell into this whole SOA, services oriented architecture, and everything is a service, which led to a lot of these monolithic systems, if you will. And then I guess the whole microservices is going to save the world. Microservices, polyglot programming, and cloud, right? They all kind
Yep.
of hit us on the similar kind of a time horizon. And everyone wanted to be the next Amazon, right? Because they have been able to do successfully, then Netflix was able to do it successfully, and so did Google, and who not. And so certainly we just need to do microservices, we need to do cloud, and maybe a little bit of domain driven design somewhere here and there, but that's it, right? That's the secret recipe of you being a successful $1 trillion company. That's it.
Yeah, and my experience from that particular client with the com objects from way back when was that they were surprised and dismayed when it didn't just work, and that left them in a world of hurt, which is how I ended up getting involved. Um, I'm guessing the same thing keeps happening over and over again. Is that true? Do you see this with microservices?
History repeats itself is sometimes what someone famously said. You know, and it's not necessary that people are kind of trying to do the same thing, but it's like a different flavor. But unfortunately, the pattern kind of repeats, and maybe there is that set of common misconceptions that we might kind of continue with a new technology or new approach, but that misconception might kind of still be there. And that's probably where to your example, right, a lot of people in enterprises that I've worked believe that when they move to microservices, they can have independent teams work on these little microservices and keep continuously deploying them to production at lightning speed, right? 1,000 deployments per day and stuff like that. And that is true when they start off, right? When they start, they certainly have microservices that can be built and rolled out in a day or 2 days, and they can keep shipping to production very easily. Up till they realize that what you just deployed ended up breaking something, right? And then people are like, okay, we need to put some speed bumps on the way before you just goes blazing fast to production. So what are we going to do is we're going to just bring this microservice and that microservice and these 3 4 microservices that depend on each other, and we're going to test them in this integration testing environment before we're going to go to production. And it makes perfect sense. Yeah, you want to take the related microservices, bring them together, make sure that the functional aspect is working, and then we will go to production. And soon, it's like, okay, these 5 6 is not sufficient, you need a few more, a few more, a few more, to the point that essentially you got to deploy all your 40,000 microservices, and hell, who knows what version of which is running in what, and what's the agreement between these. And when something breaks, it's just very very difficult to know, to pinpoint why this flow did not work, right? Or why this business scenario that you were trying to execute did not work, because something along the way kind of failed. And then came this nice little idea of observability, right? So only if I had observability, then I could just know exactly, I could pinpoint to the line of code that broke, and I could I could solve these problems like that. So that's when this whole craziness with Kubernetes and whatnot, I think, started. Anyway, but that's the problem I see is, and there's nothing wrong with the desire of having systems that can be completely isolated and worked and then deployed independently, right? So all of us desire complex systems to be broken down into meaningful chunks. Call it microservices, call it macro services, call it nano services, whatever you will. But all of us desire to be able to take large complex systems, break it down into smaller chunks, and kind of isolate them and test them in isolation. But also define like the boundaries in a clear manner, in a clear, accountable manner, where you can ensure that as you evolve, right? Because all of these things will continue to evolve. So as you evolve, those things continue to fit together. The jigsaw puzzle continues to fit together, right? And so that's where I feel a lot of challenges I'm seeing in the industry is that first few months of microservices great, right? But as the jigsaw puzzle gets more and more complicated, trying to assemble everything back in shape, making sure the contracts between them are because what you're essentially doing is when you're breaking down the system, you are taking a lot of the thought process that was hidden inside the system, and you're kind of bubbling it to the interface, And so if your interface design is not well thought through and well documented and well articulated, then what people loosely call integration problems or integration hell is what you will end up with, right? So a lot of people have now microservices, and they're finding that it's essentially a distributed monolith, and you effectively have to deploy the whole thing, test the whole thing before you can release anything, and that kills the productivity, the speed, and the velocity.
Totally. I mean, it was supposed to solve for all of those problems, and now it's actually even more complex because a distributed system is so much more difficult to manage than a non-distributed system.
Absolutely.
And so it in the worst cases, I imagine that it could make the world actually much harder to deal with.
Yeah, more hardware, more cost of running these systems. You need to have really good observability to understand what is going on. You need centralized logging, you need distributed tracing. All of these things suddenly become a prerequisite. And so my advice generally is, if you can avoid microservices, please do, because the price to pay for it is too high, and to get it right is not trivial.
Yeah, and getting it right isn't as simple as just do some domain driven design and now it's going to be perfect, right? It's getting it right must. So I'll give you an example from that situation from years ago. I remember before I was onboarded as a consultant there, I was having the discussions to see if I could help at all. And I was having a discussion with a couple of the developers who were so enamored of the idea that they just create their little well-bounded thing and then test the heck out of that and that'll be good enough. But they were puzzled by the kinds of bugs that were showing up when the system as a whole came together. And one example they gave me was, well, how could can we test around, oh, maybe these were the developers who were insisting it wasn't possible to do unit testing. Like this particular organization, as I recall, had some disparities of opinion from the people who believed that if you just do all of your unit testing really well, then you don't have to do integration testing. And then they're the ones that were saying unit testing is a waste of time. Incidentally, an argument I have had many times with
Yeah.
people, but unit testing is a waste of time because you're not going to find the bugs until you get into integration testing anyway. And so I think these were on the integration side of things, these people. But they were arguing with me and saying, well, how could you even discover a problem like this one? And the one that they described was a thing where there was a persistent store behind the scenes that everything worked with. And remember, this was not microservices. So there was not a microservice in charge of the persistent store. It was, which is already causing problems. You're already doing this with your COM objects. But this one creates an object. And then you can also delete it, but this one does something with the object. So this one gets this notification that there's an object in the database to deal with, but then this one deletes it before this one gets around to doing anything with it. And then this one blows up because it got essentially a null pointer exception. And I'm like, well, did you do unit testing around what happens if this thing gets a null pointer? Well, no. Okay, there's your problem. couldn't you like, but I feel like that was just one tiny little narrow example of the kinds of things that can go wrong when you've got collaborators that operate inside their own process space, right? Like what goes wrong? People have this idea that and it will just be fine. And Jerry Weinberg said that just is a lullaby word that is
Yeah.
designed to like that you can always translate just as we'll have great trouble. So just be fine. We'll have great trouble being fine. But what are some of the other things that go wrong that when you have a microservices architecture where maybe you've done all the things that the industry tells you you're supposed to do, you rubbed some domain driven design on it, you did a lot of unit testing, you tested the snot out of it, and things still happen in production? What are some of the things that go wrong?
Lots can go wrong, actually. For a simple scenario is, these things are distributed over a network, and there could be a network latency. So you expect something to respond back, and what if it does not respond back within the allowed time, right? Like a timeout scenario. Sure, you can unit test the timeout scenario. You can say, okay, how will I gracefully handle that? You can also do things for back pressure and things like that when you are not able to process as fast as someone's expecting you to process, and so you can kind of do things like back pressure and stuff like that. But the thing is, you know how easy is it for someone who's going to consume your microservice to understand what to expect from the microservice, right? And in spite of like a lot of effort to document these things and stuff like that, I don't think we've been able to really solve that problem very nicely, right? So one of the attempts was to take each of the microservices and define an API specification for them, right? Things like Swagger or Open API and things like that. And that's one of the things that always surprises me. So you walk into a team and they say, "Oh, we have all our services, all of them are documented really well. So now our consumers can easily know what it is, and then look at the API specification and then go and build their stuff, right? Basis that." So and of course people believe that, and they start looking at the specification and they start building things, and they like everything is great until they come to the integration environment and they find things like, oh, this key has a camel case, while in the specification the key had a slightly different case, and now my stuff is blowing up. Or when we started, we didn't have this as a mandatory thing, but along the way, the provider realized that this is mandatory and changed it, but the consumer is not sending the mandatory key or things like that. So the challenge is understanding what to expect, but also as it evolves, how to stay in sync and not fall apart, right? And so you'd see a lot of problems originating from that kind of root cause, which surface as very different and problematic problems much later in the cycle. Even the funny thing is, a lot of people have specification, but who's ensuring those the implementation is as per the specification, right? So I have a specification. I remember one of the big topics we had discussed back at the AFTT was essentially like specification driven, or at least for me it was acceptance driven development or acceptance driven testing, or acceptance driven design. Is like, here's what is a set of valid acceptance tests. Now how do I design to make sure my implementation is adhering to that acceptance test? And because these were things that you could execute, you could get instant feedback. But if you just had a document, then what do you do, right? And this, I think, was the genesis of the idea that what Cunningham had when he built Fit, right? Is instead of having these Excel sheets, can we put them into a table and then turn this HTML table into a little bit executable thing, so you can get feedback. The analysts could get feedback saying, okay, I have this really complex formula that I'm trying to compute something, and now I can put all the values and hit this thing, and it'll run against the code and tell me if it works or not, right? When it comes to API specifications, the API specifications are just documents, but they don't necessarily have that kind of feedback loop for you, right? So that's like one of the set of challenges that I see. The second is just the dealing with the scale and stuff like that, right? A lot of times the non-functional aspects are not very clearly articulated. What kind of load is this system going to handle? What's the latency that you're expecting from the system to respond back? One of the systems I worked on had about 60,000 rps, requests per second, and latency of 300 milliseconds. So it had to respond within 300 milliseconds. So when you put that into perspective and you say, okay, I need to build a system that can handle that, and wait a second, there's one other non-functional requirement: this system can never go down, because if this system goes down, then basically people can't like make calls, for example, right? Like no one will be able to place a call. So this system always has to be up and running. So when you articulate some of these non-functional requirements and then try to model your microservices to make sure that you're going to honor like a 300 millisecond response time on every end customer request, it becomes very interesting how you're going to model things, how you're going to structure things, whether you're going to do it asynchronous by design because you need to handle 60,000 requests per second, but then how do you fulfill the latency requirements and stuff like that. I think some of those things gets very interesting and complicated at the same time for people designing like near real time systems using microservices kind of an approach. So that's another problem that I see quite often is just how you handle and manage non-functional aspects. Yeah, I think so. Those two, three things I think have been like highlights for me, usually working with different enterprises.
Cool. And the as organizations redid their systems as microservices, and so they did that whole transformation thing, and then things started to go wrong. The solution that I see a lot of enterprises adopt is one of then bringing back the heavyweight testing at the end of the cycle.
Correct.
And the problem there is kind of obvious. It's that now there's this huge latency. There's the feedback latency problem, where number one, as a developer, if I'm working on this little microservice, it could actually be like 3 months before I find out that I made a change that violated expectations of other parts of the system. And so now I have to interrupt whatever it was that I'm doing and wrap my head around that change that I made 3 months ago. And so there's the feedback latency problem. But there's also the time to market latency problem, where we've made this investment and we want to, as a business, we want to be able to recognize the value from that investment as soon as possible. And now there's going to be this delay while we go back and do the rework necessary to make things all fit together. So it's, there is a lot of pressure on organizations to figure out whether they have a separate QA group or however it is that they're managing it. There's still end of cycle testing that's happening that is causing issues that then in turn cause the organization as a whole to put more pressure on the system, at which point then people end up taking shortcuts and bad things happen. And like, I'm wondering from you, because you have so much experience with large enterprises, how do you think about getting out of that trap? Because that's a trap.
That's
That's
a
just going to get worse and worse and worse, right?
very well put, right? Like it's a classic inspection trap, right? Like, oh, we'll just deploy all of these things and test them, and then we'll take it to production. But the first problem typically you will hit when you try to do that is having a stable environment. Like, it's so obvious, but I think it's in reality most organizations. And like I remember specifically working with one organization where all I was requesting people to do is just record on a wiki how much downtime the system had, and they couldn't test because some microservice was getting deployed, or some microservice contract broke and they were waiting for that to be fixed, because without that being fixed, it's on the critical path, I can't move forward with testing, right? Or someone made a change to a microservice and now I have to redo my testing, or any one of those things, right? But there is, if we started recording the amount of time that that the environment was stable for someone to actually test, and that was 70% downtime, right? So it's something that is not very obvious to a lot of people, but with more moving parts, more things can go wrong, which means the stability of the environment where you're hoping to test all of these end to end becomes fragile and less reliable. So a lot of times people end up like repeating the same set of tests to make sure it actually works or does not work. It's a false positive, false negative, like let me try and figure out. So that's one problem people will hit. And it'll also be, now that you have so many microservices, how do you ensure the test data between all of these systems are in sync, right? So that becomes the next roadblock. But let's assume you kind of try and solve those two things, but the fact that you're trying to bring all these things together and then realizing something's broken, which might be one service is not able to talk to another service, now puts everybody on hold, right? And of course, nobody is going to wait, because everyone went to this world because they wanted to ship things faster. So what they're going to do is they're like, okay, while we wait, we're going to build this other thing and we're going to push that in, right? So you now have this pile up happening, right? Where more and more stuff keeps coming in, and you're like, oh, I will just test all of this stuff together and make a release. And yes, just
I will just test this stuff. Sorry, keep going. I didn't mean to interrupt.
and so what ends up happening is you then end up with this pile up, right? So the train never leaves the station because someone or the other is inevitably late. And while they're waiting, the other passengers are now probably trying to build something else and push it in, right? Because they don't want to miss the train. And so that's another problem that will just lead to slowing everything down, right? And then there are some actual real technical challenges which are, the complexity has increased. Now there's so many moving parts, and how do you ensure all of those moving parts are in sync? I'm not even going to talk about versioning microservices. That's a whole another rabbit hole that we can go down. But like, how do you ensure that we have all the right versions of things deployed and they're all consistent with what is supposed to go to the production? Do you have like one big CI pipeline that is responsible for deploying everything in, or do you have each microservice has its own CI pipeline, which means then how do I orchestrate across all of these different microservices which version of what artifact is supposed to be deployed, etc., etc. Like, so this what it seems like a very simple and obvious idea of like, I'm just going to have the microservices and keep deploying them easily, ends up now, keep piling on, complexity keeps increasing. It leads into this whole CI/CD, DevOps, and observability analysis. What then ends up happening is you end up releasing once in 6 months, and in spite of doing your best effort, you still end up leaking a lot of bugs to production, and now everybody's unhappy, right?
Yeah.
Everybody's unhappy because they've all spent significant amount of time to try and get these features out of the door as quickly as possible. That didn't happen because someone just broke one piece of that puzzle, and now everybody gets punished for that, right? So it just creates a lot of frustration within the system. It creates delays, bug leakage still happens, and the business is not happy, the customers are not happy. So I think that was the problem we started to solve in the first place. But we kind of, after all this investment, we kind of ended up in the same place, right? So I'm just kind of just putting the backdrop, right? So that's kind of what I see happening in a lot of places. The promised benefit of microservices don't seem to be easy for organizations to realize. And throwing more people at the problem is not helping either, right? So how do you then start moving towards that promised land where you can do independent development, deployment, and independent testing, right? And based on my experience, one of the things we realized is we said, okay, when we analyzed in one particular large client that we were working with, we analyzed why their cycle time was about 6 months, and we saw that out of the 6 months, 70% of that time was actually being spent from when the dev said they were done to it actually going into production, right?
Oh,
So the
wow.
CLT, the change lead time, was about 70% of the overall cycle time. So then you double click into that 70% of the time and you see what's happening, right? So what's happening is there are now multiple environments where testing needs to happen because one is not sufficient anymore, right? You need more environments, and there is waiting times between all of those environments because the batch needs to go in and move forward. So you start keep analyzing, and then you look at the RCAs of a lot of the bugs that were filed, the root cause analysis on the bugs, and you see like 70% of those again were to do with some kind of mismatch in terms of expectation on those microservices because they were not clearly articulated, not communicated, not executable in some way, right? So that's where the idea of maybe contract testing for microservices is what needs to be brought in, and that will bring in the discipline. But not just contract testing in the end, but actually API design first kind of a thought process, right? So you kind of get the provider, the consumers, the architect, the solution architect, the integration architect, whoever you have, you bring them to the table saying, okay, this is a new feature, this is what we need to build. what is the change that needs to be done to which system, right? And here are the API specifications. These API specifications are agreed, understood by all of us. Now I'm going to make an enhancement to that API specification to incorporate this particular change that we are about to make. But first, I'm going to test whether the change that I'm just doing is backward compatible or not, right? I don't have to wait till after the development is done and then test with an old version of the app or old version of the consumer and say, oh, oops, we broke the compatibility here, right? Like, it's too late. So how can you shift that during design and get that feedback as you're designing, right? And make it a collaborative process, so that different parties can say, hey, if you're going to make this change, this is what is going to get impacted, and so forth. So what I'm trying to highlight is this whole there's a school of folks who practice what they call as API design first, where they don't just let microservice happen, right? They kind of design them, they think through the interfaces, they capture those interfaces in some kind of a central repository, and then that becomes a single source of truth for everyone to refer to. That the providers and consumers work off that, and then you ensure that as you build your microservices, you use the contract as executable tests against your specification. Similarly, if you're a consumer, then you use the contract as a way to generate a wire compatible mock for you, and then you work off it, right? And as things will evolve, things get the spec gets updated, everybody gets the single source of truth. And so what we've seen by doing this in a few places is that 70% of the contract mismatch issues that we were finding were all really being designed through and thought through and caught up front, so we're not finding those surprises later at a point. So that's one specific, at least, practice that I have seen that has helped me in several organizations to try and make this what is generally an integration hell or a testing problem, where everything just comes and piles on, to kind of start shifting that left and making it a design thing, right? It's not a testing problem, it's actually a lack of design and lack of collaboration problem. So if we can kind of get that focus right within the group, where people are looking at API design first, and then using the specifications as a way to kind of a single source of truth to keep everyone on the same page, I feel a lot of decoupling can happen. People can actually quite confidently like test things like backward compatibility, etc., etc., much before even they get to the environment, and then hopefully a very short integration again, where it could be just on demand. You spin up an ephemeral environment, you keep all the services as is fixed, you bring the one service that changed, deploy that, test, and off you go to production, right? So the whole ephemeral environment with everything fixed but just the one service that changed, I think also is very important, because if you try and bring too many changing parties at the same time, then you end up with something or the other kind of causing a problem, and then you're trying to solve all of those together just becomes too complicated.
Totally. And what I hear you describing is not trivial to do. I mean, I remember back in, it would have been about 2007, where I was working on Bring Light. I'm allowed to talk about this project by name. I love that I can, because it was one of the best projects that I had ever worked on. We had to make an investment in mocking out an external dependency that we had, a payment gateway. But then we also discovered that there were times when the behavior of the payment gateway actually didn't conform to our mock. So then we would have to like have tests that ran separately against the payment gateway, against their sandbox. And it was a simple, compared to the problems you're describing, it was a simple problem. It was one external dependency, exactly one. And it was still a pain in the butt and required investment. And I talked to other people who were working on much larger distributed systems who were having the same problem. And I described the solution that we had found. And they said, oh, that's very cute that you think that this is going to be something that we could invest in, because it's going to require a massive investment. How can you make that tractable, given that it is not easy to make that kind of investment up front?
The good news, I think, is that quite a quite a few interesting open source projects have come in this space to try and address some of these challenges. So you talked about dealing with external dependencies, for example, right? And typically, like you would get a sandbox against which you would work, but that sandbox may also like go down or not be available or rate limited. A lot of times you get some sandbox, but you're rate limited and you can't just keep bombarding with your automated tests and whatnot, right? So is there a way to create a wire compatible ephemeral sandbox for yourself which is fully under your control, right? But that doesn't go stale, that doesn't go out of sync with the real thing, right? And it's essentially the same thought process that needs to be applied to all of the other things, right? Now the challenge is, how do you make sure they don't go out of sync, and how do you make sure that that sandbox is extremely lightweight but wire compatible with what you're trying to do? And so there are open source projects. I've built one myself called Specmatic that allows you to do this exact same thing, where you can take a specification, right, like an open API specification or an async API specification, or if you're using GraphQL or gRPC, for example, you could take a protobuf and you could spin up a wire compatible mock out of it. So you're not writing any code to do that. And second is, because like I mentioned earlier, you work off that single source of truth, then the maintenance or going out of sync doesn't happen, because you're all referring to the same source of truth. Of course, you can't boil the ocean and start doing this across the board on day one. But if you start where it starts hurting you the most, where you're seeing a lot of really fast changes happening, you might want to start there, kind of adopting this kind of an approach, and then gradually scale it out. And so I do believe that today, and we've worked with some really large, complex organizations with 40,000 plus microservices, we've been able to roll this kind of an approach out. Of course, it took us, a good 6 to 8 months to get it going, but it obviously had to start small. People had to see the value in this and kind of scale that out over a period of time. So I do believe today we have tools out there that allow us to do some of these things. It's also, like you rightly pointed out, one is the tooling aspect. The second is the mindset aspect, right? Like when people look at it from that lens, where I don't trust unless everything is integrated in testing, then it's hard, right? This is more of the inspection mindset, right, where I want everything to be put together. And and generally I ask them the question, imagine you want to buy a car, right? And the people who built the car basically just assembled the whole thing. They have not tested the individual things meet the specification, right? The engine, does it meet the specification? Is it like a 800cc engine? Is it really 800cc engine? Or it's supposed to have four pistons. Does it really have four pistons, or whatever, right? Let's assume they've just assembled the car, and you want to buy the car, and so you don't believe in testing things in isolation. So you're just going to test drive the car and then believe for yourself whether it's good or not. Would you sit in the car? And most people are like, no, hell not, right? I'm not going to. But it's the same thought processes, right? Is if you believe that everything has to come together and only then you can be confident, then it's too late, it's too risky, right? You've got to figure out how you can design your systems so that you can decouple them and test them, and have ways to make sure that when they come together, they are not looking at two different sources of truth, which means they've drifted apart, and hence the integration becomes harder. And of course, I'm not saying that you never need to do any integration, but the point I'm trying to make is, the more you shift this to design time, the less you have to deal with at testing time, right? And there's a lot of really good tools out there to help you do this.
Yeah, I mean, it occurs to me that the inspection mindset problem. So many organizations are trying to have actually succeeded in the world of Agile, they've actually succeeded in doing more or less the same thing they were doing, just do it faster. I mean, like a lot of organizations had to fundamentally transform, but some organizations were sufficiently efficient that they were actually able to keep doing the same thing, only faster. But as we get into the world of AI, where we can pump out code faster than ever before, and you said 70% of the time was spent from the time that the code is done to the time that the code is, released. That you can't just keep doing the same thing and do it faster when the developers are able to pump out that much more code. I mean, there are a whole bunch of other things we could talk about with quality and AI, but we live in a fundamentally different world right now. And
Yeah.
so making this transition is so critical. Otherwise, I don't even know how an organization is going to continue to change things in this new world.
I think that's the big, you're absolutely right, Elizabeth. I think that's the big challenge a lot of organizations are fearful of, is that in a AI non-deterministic, algorithms world, uh, how are you going to deterministically test things at the end of cycle and assure quality that you can verify, because inherently those systems are non-deterministic. They, you try them 10 times and each time they will give you a slightly different answer. So how do you now bring an inspection mindset to this and make sure that everything's going to be fine? I'm not saying you don't need any inspection. You might need, but how much do you want to rely on it, and how much practically you can actually, given, like you rightly pointed out, the speed at which things can now come, right? Like, so we have now systems where product owners are, they've already fed like the journey into an LLM, and all you're saying is, hey, this doesn't seem right, can you, like, make this change, and it'll say, okay, to make this change I also need to touch these other things, go ahead, generate the stories for me, right? And it pumps out user stories for you by understanding, when you change this, you also need to change invoicing, you need to change this other system, you need to change these other systems. So suddenly you now have a system that's generating all of these stories for you. Then you have that being fed into a system that understands your code already very well. Maybe you've even fine tuned an LLM to understand your code context much better. And now you can you can literally go from that specification that someone generated to actually working code, including unit tests, right? So you can go through that whole cycle. And now you're like, okay, this is done. Next, what? I have to wait for my turn to deploy this thing into an environment where someone is going to certify, and then it's going to go out. Uh, Good luck. It's not, nobody's going to wait, right? Because the expectation has already been set that this is going to go out like at blazing fast. I mean, we've made all this investment into AI systems, and so this is just using AI to build your product, right? Like in that sense. But what if AI is your product, right? What if you are? So we touched upon Convention earlier, right? So I'll give you an example from there. When a person goes in and tries to put in a proposal to speak at a conference, what typically happens is someone puts in a proposal, there is a program committee, the program committee then looks at the proposal, gives feedback to the speaker or potential speaker, they refine the proposal, then you go through the same cycle, and then finally you look at the 300 400 proposals you've got and you shortlist the ones that fit into your conference, right? Now in an AI world, that's not how it's going to operate, right? As I'm going to be putting in my proposal, I would have a simple thing that's just going to give me feedback saying, hey, you know first of all, like you're saying this proposal fits into this theme, but based on your description I'm not sure if it actually fits into this theme, right? Because it understands the context and things like that. So now imagine I'm building a feature which is giving a potential speaker feedback, as basically I have an automated program committee member who's giving you real time feedback as you are putting in the proposal. right? That's the feature I'm building. How are you going to test that?
Yep.
Because this is not a, sure, you're going to so there are things like you're going to check for content relevance, right? You're going to check for things like, what this person has put as factual is not cooked up. What if another AI was actually writing the proposal itself now, right? You want to,
It's the battle of the
safeguard
AIs.
against that. You want to check for things like toxicity in the proposal, or you want to check for things like tone and style, and things like that. So now you would have different kinds of prompts in your LLM to try and make sure that you are providing feedback to the person who's filling in a proposal for all of these aspects. You also have done a bit of training on the model itself by feeding in the 50,000 odd proposals we have in the system, so that you can like provide all that collective intelligence into the person providing, right? Now, how are you going to test that this guy, whatever feedback the system is giving, is actually meaningful, right? Sure, you can go and try a few, but you never know, because the next time you're going to try, it could be different, right? So what are you going to do to test a system like this, right? And more, so people are talking about code first systems, or data first systems, or AI first systems, right? And so each one of them have a slightly different flavor in terms of what is that you want to test in that, what are the kinds of things you're going to look for it. And the more you're going to wait till someone's going to give you a fully done thing, the harder it's going to be to influence the testability of it, right? And again, this problem is not new. Like I think we discussed the other day, these problems have existed. I mean, AI is not something that was born yesterday, right? In fact, the funny story, like a backdrop, right? I actually started my career building neural networks for classifying remote satellite images, and of course, neural networks were pretty bad back in the day, so it couldn't do much. But even then, you would ask yourself, like, how are you going to test whether the classification that you have done is correct or not? And it's not a small image that you're looking at. You're looking at a satellite image of an entire state, right? And that's maybe like 1 terabyte in size itself, right? So how are you going to make sure that the classification is all correct, and so forth, right? So these problems have been there. I'm sure, like for people who've worked on recommendation engines and stuff like that, this is again a known problem. The style of testing some of these systems is very different, right? You need to think from the design time in terms of how do you model these systems, how do you structure them, how do you build in some form of A/B testing or comparability, or what some folks call shadow mode testing. How are you going to build some of this capability into your design so that you can do comparative analysis? You can do things like that that gives you confidence that yes, this system is going to behave the way I anticipate it to behave, and I'm confident for it to be deployed, because a lot is changing, right? The models are changing, the prompts are changing, the data itself is changing, what is being fed in is changing. And so how do you account for all of these aspects and test I'm not saying that it's not possible. It's certainly something that I think people are trying to figure out better and better ways to do. But what I know for sure is an inspection based approach is not the answer for this. And so that's what is going to be interesting, is to see how organizations transform, to address more and more non-deterministic systems, right? uh, and again, there are pragmatic approaches to look at it. You can take a non-deterministic system, like if you have a system that's like, let's say, an agentic workflow that is going to generate APIs for you, right? Like from a specification. What you could do is you could put a deterministic system around it, right? And again, a deterministic system around it to make sure that the non-deterministic system operates within bounds. So when it produces something, you have guardrails to kind of guide it, and if it's off the guardrail, you give the feedback so it kind of self-corrects, and you can start building you can start taking deterministic and non-deterministic and kind of sandwiching that in between, so you can get what you look for, right? And again, this idea is been around, right? For folks who are familiar with property-based testing, for example, you start defining what properties you expect from the system, and then you use that as guardrails, and then let a non-deterministic system produce the code itself, but you kind of guard it with that. So all I'm trying to say is there are new approaches that are evolving, and that's kind of the style that I see more and more will become the approach, and not so much of give me the test cases and I'm going to deploy it in an environment and I'm going to go through a regression cycle around it. I think that's going to be just very difficult to keep up with, with this kind of a system.
Yeah, I love what you said about having deterministic guardrails around a non-deterministic system, as opposed to the inspection mindset, and that there is a very subtle difference between the two, but it's a critical difference, because somebody could say my inspections are the deterministic guardrails. No, they're not. They really aren't, because you're talking about shifting all of this to design time. So it's no longer a testing problem, it's a design problem.
Correct.
Yeah, that is
You're
so
catching
cool.
these things as they are getting produced, not after the fact, right? So it's not
Yes.
inspection in that sense. It's also that it's real time feedback being fed back into an LLM or whatever you have, which basically then adapts the output it's producing to match that. It's not after the fact.
It's
It's
during.
it's during. It's a little bit like what Toyota did with the looms, is building those little bit of like small levers on top of the each of the threads, so when they break it kind of goes and jams the machine. It's like feedback to kind of stop that, or and on kind of a thing. But it's lot more powerful, I think, because we are really having things as it's like a lot of new stuff is going to get generated, and you should be able to handle that within a deterministic bound.
I would love to know, there are enterprises out there that are in a world of hurt right now, and people working in those enterprises struggling with all of the problems that we've talked about throughout this video. If they could do just one thing starting today or tomorrow, one thing that is going to help get them back into a healthier, like their organization back into a healthier place, what's your advice?
That's a very hard question. It's a very hard question, because I think a lot would depend on the context of the organization itself. But if I were to cook up an organization in my head, or reflect on one of the ones that I've recently worked, a lot of focus, at least personally for me, has been to try and get organizations to think about. So we've talked a lot about shift left over the years, right? But unfortunately, I feel it's become a little bit of a cliche these days to just say shift left, right? What does that even really mean? I think is a question mark. So I'm trying to refrain from using phrases like shift left or whatever, or like platform engineering and like push things down, shift down, right? A lot of people talk about like shift down, right? Like build really amazing platforms that people. I think those are all good ideas, but I think again, in reality, a lot of organizations struggle with actually making them work for them, right? So if I were to give one advice, I would go back to one size does not fit all, right? But what does help is ability to collect data, reflect on it, and then go on a bit of a continuous improvement kind of a mindset, right? And so you could look at what's it's not, you don't have to find what's your biggest problem and try and tackle that. You just need to get into a habit of trying to get the positive feedback loop kicking in, where you take any problem, try and solve that by using a little bit of like this data driven continuous improvement mindset. And then you kind of keep tackling one problem after another problem. Really doesn't matter if that's the biggest problem you have, smallest problem you have, just get into a habit of closing the loop on that. I feel like that can really take organizations a long way. And this could be, you can contextualize that in the context of testing related challenges or quality engineering related challenges. It could be in like a lot of organizations struggle with the problem what I referred to as garbage in garbage out, right? So if you don't really know where you're headed, you can keep building, can produce a feature factory and keep shipping more and more features, but is it really going to get you where you need to go? Probably not, right? So again, like, problems may lie at very different places, but get into the build the muscle for being able to take something and go through the loop quickly. And so the more that muscle gets stronger within the organization to do, I feel like they can get closer and closer to where they need to be. So I would say that's kind of the thought process that I would start with.